Okay, today we're going to continue finding the area of different shapes. Today we're going to do trapezoids, rhombuses, and kites. So the first thing that we need to make sure, and again, we've already done this before, and we struggled with finding the area, especially when we're missing certain information. So we need to make sure that the things that we need to have in order to find the area are going to be both of our bases, which in this case is going to be the two parallel sides of my trapezoid, and then the height, which is the distance, again, perpendicular distance or perpendicular height between the two bases. So when we go through these, I'm going to use a lot of color to make sure that we understand what we're missing and what we have to find. So with the first problem here, again, I'm just going to kind of darken in, and you guys should darken in these right angles here. And so we need to recognize that this is a rectangle right here. This piece is a rectangle. And so I know if this is 6 feet, that this will be 6 feet as well. And so if I'm, the things that I have already is I have the one base, which is 6 feet. I have this base here as well, which in total is going to end up being 9 feet. And so the only thing that I'm missing is my height in between. So I'm going to label that H. And so to find my height, again, I'm going to use the fact that this triangle right here is a right triangle, and so I can use the Pythagorean theorem to figure out. Again, if my right angle's right here, that means that 5 is my hypotenuse, which is the one that's by itself. So 5 squared is equal to 3 squared plus h squared. So 5 squared is 25, 3 squared is 9, 25 minus 9 gives me 16 is equal to h squared. And then take the square root of both sides, and I get my height. It ends up being 4. From there, I can plug everything in because I have both of my bases and my height now. So I go area is equal to 1/2 times my height, which is 4, and then in parentheses, I can add together my two bases, which is going to be 6 plus 9. So when I do that, I get 30. And again, these are, I believe these are feet, yep. So 30 square feet. This one, again, is a little tricky, so, well, yeah. So again, identifying what I know. I've got the top and I've got the bottom. Those are my two bases. Again, I've got these right angles in here showing me that if I dropped a perpendicular down, right like that, this shape would be a rectangle. And so again, the only thing that I'm missing that I have to find out here is going to end up being my height. So I'm going to label it H again. And so again, if this whole bottom is 7, this top is 5, I know that this piece right here is going to be 5 as well because it's a rectangle. And so I know that just this piece right here is going to end up being 2 meters. I can do 7, the entire thing, minus the piece that is of the rectangle, which is 5. Once I'm here, now I can use trig. So I'm going to use the 60-degree angle, I'm going to use H, and I'm going to use 2. So from the 60-degree angle, H is opposite, 2 is adjacent, so I'm going to go tangent of 60 is equal to H over 2. So again, when I solve, I always multiply by both sides, whatever's on the bottom. So I multiply both sides by 2. So 2 times the tangent of 60 gives me 3.46. So once I know my height is 3.46, now I have everything that I need to solve, to find the area. So I can go area is equal to 1/2 times my height, which is 3.46. And then I can add together the bases, which would be, again, 5 and 7. When I do that, I get 0.5 times 3.46, and then add together 5 and 7, which is 12. I get 20.76. These are meters, and so these are square meters. Next two, again, just kind of stepping it up a little bit. So with these problems, I'm just kind of writing my labels down here. So AB is going to be 12. This entire thing is 12. BC is going to end up being 6. and then this angle right here is going to be 30 degrees. So again, same thing, I've got a right trapezoid, like that. And so I have this entire piece right here, and what I need to find is my height, and then I also need to find out this top piece as well. Because remember that 12 is the entire length AB, and so I need to find out what H is. And then, if we can follow me through this, if I figured out, so I want to find out what this top base is, if I knew what just this piece was right here, then I could subtract it off to find out what just this piece is right here. So what I want to do is I want to figure out what this is. I'm going to label it X, and if I find out what X is, I can subtract it off of 12, and when I do that, then I can find out what that top base is. So I'm actually going to use trig twice here. So using the 30 degrees, using the H, and using the 6. Again, H is opposite, 6 is hypotenuse, so I'm going to go sine of 30 is equal to H over 6. Multiply both sides by 6. 6 times the sine of 30 gives me 3. So my height is 3. And then, so I have my height, now all I have to do is figure out what X is. There's a number of ways that I could do it. I could either use the Pythagorean theorem because I have two whole number sides of my, again, not rounded, sides of my triangle. I think I'm going to use trig just to kind of help refresh our memories. So I'm still using the 30. Now I want to find out what X is, and then again I'm going to use what was originally given to me, just in case in the future we get a decimal, so I'm going to use those three things I circled in red. So that would be cosine because X is adjacent and 6 is hypotenuse. So I'm going to go cosine of 30 is equal to X over 6. So again, multiply both sides by 6. 6 times the cosine of 30, and that gives me 5, let's see, X is equal to 5.196, so 5.20. And so again, if X is 5.2, then I would know, again, just by doing math, doing 12 minus 5.2, I would get 6.8 for my top base. And so what I can do is, again, plug those in. My area is equal to 1/2 times my height, which was 3, and then add my bases together, which is 12 plus, and then 6.8. 0.5, oops, times 3, parentheses 12 plus 6.8, I get 28.2. Those would be square units. Same thing with the next one. Again, I'm given AB, which is 3. Again, this entire thing is AB. That entire thing is 3. I'm given CD, which is 1. And then I'm given that B is a 45-degree angle. So again, the only thing that I'm missing here is this height. And so in the same way, I can find out what this piece is right here. Again, knowing that CD is going to be 1, I would know that this piece right here is also 1, so I would know that this piece right here is 2. Again, I want to find out what my height is. That's the only thing I'm missing. And so using the 45-degree angle, so from the 45, using H and using 2, I would use tangent because that's opposite. H is opposite and 2 is adjacent. And so I would go tangent of 45 is equal to H over 2. I can multiply both sides by 2 and get that my height is going to be 2 as well. Once I'm there, I can plug, I have everything. I have my bases and my height. So I'm going to go area is equal to 1/2 times my height, which is 2. And then add my bases together, 3 plus 1. So I get my area to equal 4 square units. There we go. then this last trapezoid that we have here, again, same picture, just given different information. I know that AE is going to be 10, BC is 12, and then angle B is going to be 60. And so what I connect CE together, that's going to be a rectangle again, just like we've done here. And so again, I know, since AE is 10, I know that this piece is going to be 10 as well. So I know what my top base is. I know what this piece is, but I don't know what this last piece of my bottom base is. So I have to figure out what BE is, and then I also need to figure out what my height is in this case. So here's my H, and let's call this one X, how about? And so similarly to the one that we did 2 problems ago. So again, I'm going to use trig to find out the things that I need to know. So I'm going to use a 60-degree angle. I'm going to find H, and I'm going to use 12. So I'm going to go, again, H is opposite, 12 is hypotenuse. So I'm going sine of 60 is equal to H over 12. I can multiply them both by 12. 12 times the sine of 60. So my height ends up being 10.39. To find out what X is, again, I'm still going to use the 60. I'm going to use X, and then I don't want to use a rounded number, so I'm going to find out what 12 is. So when I'm doing that, X is adjacent and 12 is hypotenuse, so I'm going to use cosine of 60 equal to X over 12. So 12 times the cosine of 60 gives me 6. So now I have everything that I need. My top base is 10, my bottom base is 10 plus 6, which is 16, and my height is 10.39. So I can go area is equal to 1/2 times 10.39, and then add together 10 plus 16. When I do that, I get 135.07. Again, that's going to be square units. Then the last thing that we have here is just finding the areas of rhombuses and kites. What we need to make sure we understand, what I believe was a big problem the last time we did this, is we didn't understand what D1 and D2 were. They are diagonals. So going across from opposite vertices of my shape, so for this rhombus that I have in the top right-hand corner, again, the red line that I just drew is one of my vertices, and then the other is going to be my other diagonal connecting my 2 opposite vertices together. Same thing with the kite. This is my one diagonal, and then this is my other diagonal. And so when I'm doing this, this 2M is supposed to be pointing towards this segment right here that I just traced, that I can highlight in blue. So that's 2. So I know that my 2 diagonals are going to end up being KM is my one diagonal, and then LN is going to be my other diagonal. So I know that KM is going to be against 2 plus 5, which gives me 7. And then LN, my other diagonal, is going to be 3 plus 3, which is 6. And so I can use my formula, area is equal to 1/2, and then just multiply my diagonals by each other. 1/2 times 7 times 6 gives me my area is, 21. And these are meters, so square meters. With the second one, again, this vertical, this is my one diagonal, which is 6 meters long. So I know that one of my diagonals is 6. And then I'm going to have to work to find my other diagonal. So again, this is the other one that I want to find. Remember that rhombus's diagonals bisect each other and they're perpendicular. So I know that these guys are going to meet at a right angle. And I know that they're going to cut each other in half, so this one, both these little pieces are going to be 3 because the entire thing is 6. And so again, if I've got right angle here, I can use this triangle and make it a right triangle to find the missing piece. So when I do that, again, I'm going to go 5 is my hypotenuse, so it's 5 squared is equal to 3 squared plus, and how about I name this x squared. So 5 squared minus 3 squared gives me 16 is equal to x squared. Square root of both sides, so x is equal to 4. So I know that this piece right here is 4, which means that this piece here is 4 as well. So my second diagonal, my diagonal that's horizontal, is going to be 8 meters total. So I go area is equal to 1/2 times my diagonals, which are 6 and 8. So my area is equal to, let's see, 48, so 24 square meters. There we go.